Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
All right, guys, welcome back again in the second hour for today. Okay, so we were talking about the Voltaic cell. So I'm going to show you again the video, the same video with the last video. Yeah, we watched. We're going to watch again from the beginning and try to remember what we see in the previous session. Right, we were talking about this, the Voltaic cell.
When a strip of zinc metal is immersed in an aqueous copper-2 sulfate solution, electrons are transferred from zinc to the copper-2 ions. Copper metal deposits on the zinc strip and collects at the bottom of the flask. Zinc atoms are oxidized to zinc-2 ions, which enter the solution. This spontaneous oxidation-reduction reaction is summarized in the chemical equation shown. The spontaneous copper-zinc oxidation-reduction reaction can be made to yield useful electrical work by incorporating it in a Voltaic cell. The zinc electrode is immersed in a solution of zinc sulfate. The copper electrode is immersed in a solution of copper-2 sulfate. No current flows through the light bulb because the electrical circuit is not complete. To complete the electrical circuit, we add a tubular bridge filled with aqueous sodium sulfate solution with a porous plug on each end. We now have a complete circuit and current flows. When we replace the light bulb with a voltmeter, we find that the cell has a potential or voltage of 1.1 volts. The copper electrode is the positive electrode, and the zinc electrode is the negative electrode. As the cell reaction proceeds, zinc atoms of the zinc electrode lose electrons and move into the solution as zinc ions. At the same time, copper-2 ions acquire electrons at the copper electrode and form copper metal. The reaction in the left-hand compartment is oxidation of zinc. The electrode at which oxidation occurs is called the anode.
Where oxidation occurs, the place is anode. Reduction occurs, cathode. Okay, lastly, we stop in here.
The reaction in the right-hand compartment is reduction of copper. The electrode at which reduction occurs is called the cathode. Electrons flow from the...
Now look at the electron flowing. As we can see here, electron is flowing from negative to the positive, isn't it? Electron flowing from negative to positive. Why electron is coming from here? Because here zinc is oxidized and it's released to electron here in this compartment. So that's why this 2 electron is released from the zinc is going to these wires and go to the right compartment where there's a copper electrode. What happened here? The electron that coming to this copper electrode will be captured by this copper solution, copper ions, and this copper ion will reduce. After it's captured to electron, it will reduce into copper sulfate, copper solid, and it will deposit it here in the copper electrode. So there will be an electron movement from negative electrode to the positive electrode, as we say that electron moving from negative to positive. And there will be current, of course, because of the movement of the electron in the opposite direction from positive to the negative. There will be a current will come in these wires.
The anode to the cathode through the external circuit. To maintain electrical neutrality.
Okay, this is important. Anode is in negative pole. Cathode is in the positive pole. So you have to remember this. Anode oxidation, cathode reduction. Anode oxidation, cathode reduction. Anode negative, cathode positive in Voltaic cell. Sometimes it is abbreviated in Bahasa Indonesia. They say it kapan. Kapan. Kapan means cathode positive, anode negative. Kapan, ya. In Voltaic cell, we can abbreviate it like that. Kapan. Cathode positive, anode negative. You have to remember this.
In the 2 cell compartments, ions must move through the salt bridge.
So what happened now, when the reaction is going on, the electron will move from zinc electrode to the copper electrode, and is continuously moving from zinc to copper. So at one point, the number of electron in the right compartment is more negative now, because more electron we have here. But in the left compartment, it's become less negative, because the electron is moving from the left compartment to the right compartment. So the right compartment will become more negative, the left compartment will become more less negative. So this condition will make the circuit not working. If this condition is continue, the right compartment, it will become more negative, the left compartment will be less negative, and if it is continue like this, at one point the circuit will stop working, because it's too much negative here and less negative here. So that's why, to neutralize this condition, we need ions to neutralize. That ion will coming from this salt bridge. Salt bridge containing this salt, sodium sulfate. Sodium sulfate in aqueous solution, it will become sodium plus and sulfate minus, negative charge. So what happened? Because this right compartment is more negative, so the positive charge will goes to this right compartment to neutralize this condition. At the same time also here, because the left compartment is less negative, so that's why more negative ion will come to this last compartment to neutralize that condition. So that's why this salt bridge also have a function to neutralize the condition. So the circuit will continue to work. Yeah. If it is not, there is no salt bridge like this, at one point the compartment or the Voltaic cell will stop working, because too much negative in the left and the right, and less negative in the left. Okay, is it clear? Yeah.
In summary, remember that in a voltaic cell, the anode at which oxidation occurs is the negative electrode. The cathode at which reduction occurs is the positive electrode. Electrons flow through the external circuit from anode to cathode.
All right.
Zinc. The electrode at which oxidation occurs. The reaction in the right-hand compartment is the electrode at which from the anode to the cathode through the.
Okay, now I want you to draw this one in your notebook and try to write all of them. I give you some time to draw this Voltaic cell examples in your notebook. Cathode positive, anode negative, don't forget. Cathode reduction, anode oxidation. Finish? Yes, yeah. Hafiz, finish?
Belum, sir. Not yet.
Not yet. All right. Please. Let's show also the ion salt bridge here. Now it is more complete. The salt bridge also, sorry. Okay, you have to show also the salt bridge here. Finish?
Yes, sir.
All right. Good. So what we understand from here? Let's see. Alif, what you understand, Alif? You can use bahasa.
Jadi tadi mengenai Voltaic Cell di sirkuit tadi, untuk bagian positif atau katodnya ada di bagian copper, kemudian bagian negatifnya atau anodnya itu terdapat zinc. Kemudian untuk membuat sirkuit ini tertutup maka diperlukan jembatan garam Na2SO4. Mungkin itu aja.
Alright. Okay. Agus, bagaimana cara bekerjanya? How the system work?
Okay, sir.
How the system is work?
Ya.
How the voltaic cell is work?
Untuk bekerja, zinc berpindah dari cairan zinc pada zinc berpindah dari itu ke cairan copper.
Apanya yang berpindah?
Elektron.
All right. The electron is moved from zinc because zinc is oxidized, right? From zinc compartment, the electron is moved to the copper compartment. Okay. Then?
And setelah berpindah, untuk bisa masukkan reaksi yang tertutup, harus ada jembatan yang menyalurkannya. Biar nilai elektronegatifnya tidak terkumpul di cairan copper.
Alright.
Jadi perlu jembatan asam Na2SO4.
Alright.
Itu, sir.
When the system works, the right compartment, the copper compartment or the cathode will become more negative and the anode will be less negative. So to neutralize this one, you need a salt bridge, yeah, that contain the ions that will neutralize the condition. Very good. All right, let's continue then. Do you have any question? Question? All right, if there is no question, let's continue now with the cell notation. We can write the cell notation for this. Cell notation. I'm going to write the cell notation from the same voltaic cell that we saw in the video, yeah? In cell notation of the voltaic cell that we saw in the video is like this. Zinc will oxidize into zinc 2+ in salt bridge, and copper will reduce to copper solid. So this is the cell notation for that one. The left side, it is the anode. Always anode here in the left side. In the right side, always cathode. Anode, there is oxidation process in anode. As you can see here, this is oxidation process. In cathode, there is reduction process. Anode, it is negative electrode, and cathode, positive electrode. So this is how we can understand for cell notation. We say this cell notation. So in the left side, there is an anode where there is an oxidation process, zinc, single line, zinc 2+. This single line means that there is a different state between the zinc and zinc 2+. This is in solid, this is in aqueous. The same time in the cathode part on the right side, copper 2+, single line copper, it's mean that this is two different state, copper 2+ in aqueous, this copper is in solid. there is a reduction reaction here. And between these two, there are double line here. This double line show that it is a salt bridge that make the system or voltaic cell work. All right. So this is what we call a cell notation. And from this cell notation, we can calculate the E cell. What is E? I'm sorry. We can calculate E cell. E cell means is the electromotive force or voltase in bahasa Indonesia, or voltage in physics. Sometimes you use it via voltage or electromotive force, EMF. In chemistry, we use E, this E, and we add cell, E cell. And for the reaction before, the E cell value is 1.1 volt, as we can see in the volt method. Okay, now this E cell can transform into E0 cell. Yeah, if the reaction is taking place at 1 atmosphere at standard. This 0 means standard, yeah. E0 cell is standard electromotive cell. What does it mean standard? 1 atmosphere, 25 degrees Celsius or 298 Kelvin. And the solution must be 1 molar. When you look at the previous reaction, it is at standard condition. So we can say that a previous reaction is also E0 cell because it is at 1 atmosphere, 25 degrees Celsius, and 1 molar solution for both compartment. Okay, is it clear? Nilai E0 cell itu maksudnya apa? Jelas ya? Alright. Now, actually, this E cell can be found by looking at individual E value. What does mean individual E value? We have two E value, E0 red and E0 ox atau oxy. E0 red, it's mean that E0 only for half cell, the one which is in reduction. And E0 ox is mean that the E0 which is only one cell in the oxidation. We have two compartments, right? One of them is E0 reduction, one of them is E0 oxidation. Totally, we call this E0 cell. Okay. But what we can measure is the E0 cell that come up in the voltmeter is E0 cell. Ini yang keluar E0 cell. So we cannot find E0 reduction and E0 oxidation because this is two unknown thing. We have only the E0 cell. That's why we have to use another thing to find E0 reduction or E0 oxidation. But by convention, convention of the chemists, they prefer to use E0 reduction, not E0 oxidation. They prefer to use E0 reduction, not E0 oxidation. If E0 reduction is found, then E0 oxidation is actually can be found if you know the E0 cell. So that's why they need to use what we call that one, let's say the standard, yeah, to find the E0 reduction. They need a standard to find E0 reduction because if both of them are unknown, then it's difficult to find. So one of them must be known as a standard, and then the other can be found. So they choose a standard for this, and the standard is SHE. She is the standard, not he. She, not her. C is the standard. So what is this C means? C is the abbreviation for standard, hydrogen, electrode. and they accept the value for C as 0 volt. It is the standard. Okay, E0 reduction, yeah, I mean E0 reduction for the E0 reduction for the C for the standard hydrogen electrode is always 0. It is the standard. So the other element can be found the E0 reduction according to the C. They will compare the E0 reduction for the other compartment by using E0 reduction of C, which is equal to 0. I'm going to show you how they found it by using a picture. Let me show you a picture. Wait a minute. We need a picture there. Yes. All right. Let me show. This is the picture of C, guys. As you can see here now, in the left side, it is what we call as a C, as a standard. Yeah, C is the standard, and the right side is the reduction. C is the standard, and the right side is the reduction. And C is accepted as 0. C is accepted as 0. And the right side, any other metal here will be found the E0 reduction. Here, for example, if I'm using copper here, yeah, if I'm using copper here, the voltmeter here will show you 0.34. Yeah, the voltmeter will show you 0.34. What does it mean? It means that because C is the standard, which is 0, it means that the copper E0 reduction of copper will be 0.34. Oke, jadi yang hidrogen ini dianggap 0. Karena dianggap 0 berarti V-nya ini, the V value only affected by this copper. If it is 0.34, if reading, the voltmeter is reading 0.34, it means that E0 of copper is 0.34. Okay, and this copper can be changed with another electrode. You can use iron to know what is the E0 reduction of iron. You can use silver, you can use zinc or any other material. And all of them can be found what is the E0 reduction for each material. Okay, we can find E0 reduction for each material by using this C compartment, because C compartment accepted as 0. Is it clear? Okay, so if we know that one, at the end, after we know that, by the way, the C is not only E reduction, yeah, the E is 0. Let me, so this is not only E reduction, it is a standard, so we accept it as 0. So if I'm using this C, I can find all data about the material. What is E0 reduction of material? I will have a E0 data for each material. And this E0 data is already given as a table in your book. So you don't have to report, find all the E0 reduction, yeah, for all material, because the data is already given in the table in your book. It's like periodic table, yeah, it's given data. When you open your book, page 51, please open your book, page 51. There is a table there, table 2.4, that show you that the E0 value for each of material. But E0 will always be given as a reduction value. Like I wrote here, E0 reduction data. It is not oxidation. Did you see in your book the data table? Yeah, there are so many material there is written in the table, and all of them, look at the reaction, all of them are reduction reaction, and they have E0 reduction data value, isn't it? Look at the E0 reduction data from the table. There are two types of data. We have positive and we have negative. Ada yang positif, ada yang negatif, isn't it? Dan ada yang nol. Yang nol siapa? Yang nol siapa? Come on guys.
Hydrogen.
Ya, C ini yang tadi ya. Yang nol ini C karena standar. Dia mau dibalik-balik seperti apa pun nol. Mau reduksi, mau oksidasi pasti nol nilainya. Karena dia standar. But for the others, we have positive and negative value. What does it mean positive and negative? Positive means it is the material is easy to reduction or tend to reduction, easier to reduce. Yeah, it's like to be reduction, easy if the value is positive compared with the C, compared with the hydrogen. The negative one is difficult to reduction. All right. The negative one is difficult to reduction. So this data is given in the book. Given, the data will be given. So we are not going to use the C, dihitung lagi lewat C standarnya berapa, lalu dicari E0-nya untuk setiap material, nggak perlu karena it's already given in the data table from the books. They already make the experiment and they write down the data, so we just going to use it. And remember, by the convention, the data that is given is always reduction. So we're going to use only reduction data, not the oxidation, okay? All right, is it clear up to here? All right, can I clear? All right, I clear it. All right, next one is cell potential. After cell notation, now we're going to learn cell potential. I'm going to use the same reaction, voltaic cell, yeah. Like the previous, zinc 2 plus, I'm going to write the notation, copper 2 plus, and copper. This is our cell potential. And here is anode, we know that. This is anode. Here is reduction cathode. Now, actually, if we know the data of the E0 reduction for each cell, we can easily find the E0 cell for each voltaic cell that we have. It's very easy. The formula to find the E0 cell is E0 cathode minus E0 anode. This is the formula. Let's check for our voltaic cell in our example. Now, E0 cathode, what is the cathode? Cathode is copper, right? Cathode is copper. Look at the copper from the data. What is the value of E0 for copper? E0 copper here and minus E0 zinc. because anode is zinc. What is the value of E0 copper? Yes?
plus 0.334.
Plus, yeah. Minus, what is E0 of zinc?
Negative 0.76.
All right. If I calculate this one, 0.34 minus become plus 0.76, what will be the value? 1.1.
1.1.
It is the same like we see in the experiment, isn't it? So our formula to find the E0 cell is this one, E0 cathode minus E0 anode. And this is only for Voltaic cell, yeah? This is for Voltaic cell, not for the other cell. And what is another important thing in Voltaic cell? The E0 cell will always be positive, the value. It cannot be negative. If it is negative, it means that it is not a Voltaic cell. And this positive showing you that it is a spontaneous reaction. Remember, all Voltaic cell is a spontaneous reaction. So one parameter again we see here, all the spontaneous reaction will have a positive E0 cell. Maka kita bisa ambil kesimpulan juga nih sebenarnya dari sini. Rumusnya gimana? Dari I0 yang besar dikurangi I0 yang kecil. Karena nggak mungkin yang kecil dikurangin yang besar. Kalau yang kecil dikurangin yang besar, pasti hasilnya akan negatif. Benar nggak? Karena E0 cell di Voltaic cell nggak boleh negatif, berarti selain rumus ini E cathode dikurangi E anode, berarti E besar dikurangi E kecil, bisa juga seperti itu. Ya, tapi itu untuk rumus cepatnya saja ya. But the normally is like this: E0 cathode minus E0 anode. Clear ini? Now we are going to do some exercises. If we have time, yeah. Unfortunately, we don't have time. I think I'm going to write the equation then. Can I clear this one? Right. Now let's do example. I'm going to write the equation. Given that the data of electro E0 cell Ag plus, datanya seperti ini dikasih, plus electron become Ag, and E0 is equal to E0 red, yeah. E0 red, assume for this one is plus 0.80 volt. Okay, and then second one is Mg2 plus 2 electron, producing Mg. E0 red is equal to minus 2.37 volt. Right, the equation is part A. Calculate E0 cell. If these two substance is become Voltaic cell. B. Write the reaction in each electrode. So we have two electrodes, yeah, anode and cathode. So you are going to write the reaction in each electrode, and also the reaction, cell reaction. Cell reaction, it means that a total reaction. Cell reaction. So you're going to write here cathode reaction, anode reaction, and cell reaction. All right. Try to write first the question. How to solve this question to find E0 cell? Kalau rumus cepatnya gimana? Besar dikurangi kecil ya, ya kan? So I give the hint here. So to find E0 cell, if we are using the formula, E0 cell is equal to E0 cathode, isn't it? Minus E0 anode. Now we have to choose which one is cathode. Cathode must be the bigger one. So here is cathode because it's bigger than the other, and this is anode. So from here you can find the E0 cell easily. If we want to calculate 0.80 minus 2.37, and if you calculate here, the value will be positive 3.17 volt. This is the E0 cell. Jadi cathode ini yang terreduksi ya. There's a reduction here because the cathode, and anode there is an oxidation here. Nah sekarang kita tuliskan mana reaksi di elektrodanya. Di katodanya reaksinya seperti apa? In cathode, because there is a reduction, it is already reduction. So Ag plus electron become Ag. Ya, ini reaksinya seperti itu. Nah, reaksi di anode seperti apa? Anode reaksinya oksidasi ya. So, dibalik reaksi yang di atas. Mg become Mg2 plus 2 elektron. Ini reaksi anode. Nah, reaksi totalnya bagaimana? Reaksi totalnya harus disamakan elektron. You have to make the electron equal. Ini kali 2 berarti. Supaya jadi sama. 2Ag plus 2 elektron 2Ag. Yang ini tetap Mg2 plus 2 elektron. Nah, nanti baru ditambah ini. Oke, we run out the time. Nanti dicoret ini diturunin ke bawah. We got the cell reaction. Okay, thank you. See you next lesson. We are going to continue to solve more problem in the next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.